Okay, let's do some more integration. Why don't you pause the video and try these four problems by yourself? Okay, let's put numbers here. Let me label it as, let me see, what color should I use? I'm going to put it as 1, 2, 3, 4. Let's see how it goes. Let's see, number 1 is a definite integral because we got lower bound and upper bound, 3 to 4. So let me do number 1 here. This is second power, this is first power, so I'm going to let u is equal to the x squared minus 2. Then take the derivative, you get 2x times dx. And then what you need to do is you have x dx here. Don't worry about the 3, we could just put it outside. I'm going to divide it by 2, so make it 1/2 du. That's going to be equal to x dx, which is equal to that portion right there. Okay, this is u, and 3 can be put outside. Okay, let's put everything together here. Instead, so put everything. So 3 is outside now. Integrate from, well, I'm not going to write 3 and 4 yet. And then 1/2 du, so over 2, we have du. So that 3 came from this 3, and that 1/2 is right there, denominator 2, right there, okay? So that covers it. Here we go. And then du has a x dx in it, so that's been covered. And then it's going to be 1 over u. Okay, now that 3 and 4 was when it used to be x, so you got to plug it into here because now we have in terms of u. So 3 squared will be 9 minus 2, 8, 7. And then when you put 4, that's 16, 15, 14. So we have those bounds now. Okay, now all we got to do is integrate. So 3 over 2 times, well, isn't that ln natural log of u? We don't have to put absolute value because we know 7 and 14 is what? Positive number, right? Since it's definite integral, we don't put c, which is nice. Now all you got to do is 3 over 2 times natural log of 14, watch this, minus natural log of 7, and using property of log, it's just going to be 3 over 2 times natural log of 14 over 7, which will be 2. So that should do it for number 1. Alrighty, let's move on to number 2. Okay, let me use different color. Number 2. So we got cosine to the 5th power and then sine. Alright, let's have u is equal to cosine x this time. Then du will be, derivative of cosine will be negative sine x dx. But it's got positive sine x dx in it. So I'm going to multiply by negative 1. So negative du is now equal to sine x dx. Okay, so this portion right there is actually negative du. So now let's substitute. So integral of cosine x is u now to the 5th power, and then du, but it has to be negative, so I'm going to put negative in front. Okay, so that's what this is equal to now. Now all you got to do is integrate. So u to the 6 over 6, but you got negative here, plus c, and then just plug cosine u back in. So it's going to be negative cosine to the 6th power, everything over 6 plus c. So that will be number 2. Moving on to number 3 now. Number 3 is a little bit of a tricky one here because it's cosine cube. And if we let u is equal to cosine, whatever that is, if we take the derivative, we're going to get negative sign. There's no negative sign there, or sign. Okay, so here's a little bit of a trick you could think of. So we know that cosine cube of 7x, well, isn't that same thing as cosine square of 7x times cosine of 7x. That's exactly what it is. Okay? And then we use the fact that, watch this, sine of whatever theta, squared, I mean, plus cosine squared theta is 1. Okay? That means we got cosine squared 7x we could have in terms of sine now, because cosine square of whatever theta is actually 1 minus sine square of that theta, as long as what's inside is the same. So here's what I'm going to do. You could change cosine square 7x as, so this actually becomes 1 minus sine square. Instead of theta, I'm going to put 7x, like that. Okay? So it's that times now cosine 7x is actually what this is equal to. Okay, that's the trick here. That's the hardest part. Now we just integrate. So we're going to integrate this now. Let me put dx right there. Okay? And then we could let u, let me write it here, u is equal to just sine 7x. Then du is going to be cosine 7x, and then multiply by derivative inside, chain rule, get 7 dx. But there's no 7 in front, so I'm going to put 1 over 7 du is actually equal to cosine 7x dx. So 1 over 7 du, that will represent this portion right there. So that's equal to 1 over 7 du. Okay. Now let's plug u back in. So we have integral of 1 minus, instead of sine square 7x, I'm going to put u square, and that times du, but it's 1 over 7, so I'm going to put 1 over 7 in front. See how simpler this whole thing became? Alrighty, now just integrate. So it's going to be 1 over 7 times, well, 1 du, integrating is just u. And then that's going to be u cubed over 3. And then, let me see, is this, yeah, plus c at the end. Plug everything back in. Let me shrink this a little bit. Plug everything back in. We got 1 over 7. U used to be, let me see, sine 7x. And then minus, let's put 1/3 out. And then it's going to be sine cube 7x. And then all you got to do is plus c at the end. Ooh, plus c right there. Okay, so this should be, answer to number 3. Let's move on to number 4 now. Let me see. So we have ln 2, ln 9, and then 4 can be taken out, e to the x. Okay, we know that the derivative of e to the x is e to the x. That means integral of e to the x is also e to the x. Okay, this is actually easy. This, you just multiply by 4, and then e to the x. Integral of e to the x is just e to the x. And then you want to go from natural log of 2 to the natural log of 9. Okay, so all you got to do is just plug it in now. It's 4 times e to the ln 9 minus e to the natural log of 2. That's just 4 times, well, this is just 9, and this is minus 2. So it's going to be 4 times 7, and guess what? 28, yeah. That should be it.